Hello, welcome to my talk. I know it's quite late, but I tried to make it really intense and really exciting, so you should wake up. A few remarks. I'm Oliver Drobnik. This is my email address. Cogonetics.com is my domain, where many of you have been reading my blog for many years. The whole thing is my email. Red, white, and red is Austria, where I'm from. And the thing in the middle is my Twitter handle. And it will become clear in a few moments why I'm mentioning this, but I founded two companies. One, Drobnik AG, we are doing custom iOS development for the most part for some international clients. And just last fall, we basically switched everything to Swift. And the second company I co-founded, it's basically product information you can query by barcode and get product titles like that. And that was, I did an API for that about 2 years ago. Yeah? Coming back to that soon. And also my publisher, because I wrote a book, would like to give away 2 copies of my book. So if you tweet feedback and photos of my talk, you have a chance to win a free copy. So if you do that, I will select by random 2 people and they get a free copy with hashtag #MDevCamp. And also until November, with this mentioned code, you get 39% off all Manning books. So not just mine, all of the ones about all the great topics that have been mentioned here and many others. So that I wanted to mention. But now let's get to my talk. And it's not called Survival of the Fittest, it's called Survival of the Swiftest. Let me explain. Survival of the fittest is basically the theory of evolution. Yeah? Or said in popular terms, how the giraffe got its long neck. Yeah? So the simplified version of the theory of evolution is the giraffes got a long neck because they were stretching for the higher fruit. Yeah? And the ones that did reach the higher fruit, they had an evolutionary advantage. So they bred and had baby giraffes who also had longer necks. And that's how giraffes came to have long necks. But not just that, they also came to have long legs. Yeah? So in terms of being fit, well, this lion is fit, this lion is fit, this giraffe is fit, but this giraffe is also swifter than the lions because the result of this story is this giraffe got away. Yeah? It wasn't eaten. And in terms of developer evolution, there's a thesis, a great person once said, those companies and developers will have an evolutionary advantage who keep reaching for advanced development techniques. So let's briefly look at how much Swift is actually being used. Somebody did a query of the top 100 free apps. You can look at the app bundles and see which have the Swift dynamic libraries, and he found out it's 11% of the free apps. Yeah? Tim Cook said at WWDC keynote just a few days ago that there are 2 million apps on the App Store, of which more than 100,000 adopted the use of Swift code. That's how he put it. And that's 5%. So we're somewhere between 5% and 11% of iOS apps that have more or less some amount of Swift in them. And if we look at the popularity index of certain languages, you can see here Objective-C has now dropped below the popularity of Swift. Yeah? To this, I have to also mention I was quite sad when I actually researched that because I saw that last year Java made a big comeback. So basically what Objective-C dropped, Java gained, but I think it's an unfair comparison because you also develop Android in Java. So the Android thing, and also there's a resurgence of web development in Java, all of that contributed to Java being on top here. But what you can say is basically, nevertheless, Swift is winning because Objective-C is clearly going down in popularity. Swift is continuously over the time when it's, since it was conceived 2 years ago, it's been growing and growing in popularity. There has been this Java resurgence, but since Swift was open sourced now, you will soon see it everywhere from mobile to server. Yeah? And there's this big renaming going on from Swift 2 to Swift 3 that basically serves to make the source code stable for generations to come. Yeah. Here's a interview statement that Craig Federighi uttered in December. We think Swift is the next major programming language, the one people are going to be programming over the coming several decades. We think it's a combination of being a great systems and app programming language that's fast and safe. It's being really expressive and easy to learn. Yeah, yes, I'm all for that. And also he said, we want everyone to learn Swift as their primary language. And the funny thing is, like in February, I hired my most recent developer, and he came from web, and he never started with Objective-C. He's one of these people that start with the first language as Swift, and it's a funny situation because I have some old apps that I'm basically throwing him as a bone. Yeah, look at that, modernize that, and it's like all is Objective-C. So he has to learn to read Objective-C and map that in his brain. That's this Swift concept. It's a funny situation. And he also says scripting to apps for mobile down to writing code in the cloud. So Swift is designed to be everywhere. And I'm looking forward to the day when it really will be everywhere and all Android apps and all web development will all be in Swift, because that will be the day when I can develop all these platforms. Because I'm not going to start with Java now. Yeah? I'm going to be 42, too old for that. Now, Swift, it's easy to get into Swift. You just do what you did before in Objective-C and now write it in Swift. That's too easy. That's low-hanging fruit. You don't have to stretch yourself for that. So we're not going to talk about that. I did other talks before where I said how great Swift is and how much typing you save. It's about 50% of keystrokes you save when you write the same things in Swift. We are today interested in the high-hanging fruits. Yeah? Like the giraffe, we want to evolve as a developer. And here are some Swift language features that I consider to be up there, yeah, not the junk food down there, the goodies, yeah. And these are things that don't have a representation Objective-C. Yeah? If you are developing an API, yeah, the question for you is, like I said before with these two companies, product layer, the goal was everybody should be able to use this SDK and API. So I needed to make it Objective-C compatible. Yeah? But on the other hand, we've had several new projects start, and well, if Objective-C is not any question there, yeah, I'm free to grab these things that are not compatible with Objective-C. If you have an API that, for example, uses a tuple, yeah, returns a tuple, this method you don't even see in Objective-C because there's no representation. The compiler has no way to translate that somehow that Objective-C understands it. Yeah? And I'm picking 3 things here that I'm going to package into a nice case study that I want to show you, where these 3 things make code more easy, more simpler to reason about for the compiler and easier to understand for a developer if he comes back to that. And I'm talking here about a RESTful web service. Hint, hint, that's the product layer API, yeah? Where you have HTTP requests via NS URL session data tasks. You get a response back that's asynchronous, so you will have a block-based completion handler, and the whole thing is supposed to use best practices at the time of when it was created for the first time, like 1.5 years ago, and so to ensure maximum compatibility. Yeah? And I'm talking about this, so it's on GitHub. You can look at what I'm referring to. And all these API methods, yeah, in the SDK follow more or less the same path. Yeah? You have a HTTP request that you construct and that you send off to the server. After a while, the response comes back. Yeah? That might be okay or not. If you don't have internet, you would get a NS error from the session. And if there's an error, then I would call the completion handler with this error. Yeah? If it's okay, then I would decode the JSON. That could go wrong. The JSON could be malformed or something. But if it's okay, then I create model objects out of that because I don't want to work with dictionaries all the time. I want to have solid, statically typed objects that I'm dealing with. And if it's going badly, yeah, I can't decode the JSON. Again, I call the completion handler. And in the case of success, then finally I can call the completion block with the result. Yeah? Now, the old school approach, as done in the product layer API, would be like this. I have type-defed myself a completion block that has a result and has an error. Yeah? You probably have seen this method multiple occasions before. This is how you would call this or use this as a completion handler. In this case, it's a function to search for a barcode. You specify also a language, and you get back this completion. Yeah? Either the error is filled in or the result is filled in. Yeah? There are several problems with this old school approach. Yeah? The first being that the return type of the result is not correct, is not specific. Yeah? It in Objective-C can be anything. Yeah? The second problem is that here's a generic error, and while the errors that you get back from Apple frameworks might usually be very nicely localized, typically the errors that I create in my frameworks never are. Yeah? And so you don't know what the quality of this error is. Yeah? Also, you don't know what kind of errors are even possible from this API that you're creating here. And the third thing, it needed to be tagged as nullable so that it's an optional in Swift because it can be either that or that. But the problem here is you basically have the situation that you could conceivably have both a result and an error or both nil. That's also something that you don't actually want to be possible. Yeah? And it does not model this situation that you want either a result or an error. Yeah? So if you look back at that, I want to be able to have this condition or that condition and nothing else. And the whole thing should be swiftly. Yeah? So how do we do that? Well, there are this concept called enumerations. Yeah? And we could just take these two cases, result or failure, and model that as an enum. Yeah? So we have a case success. That's the case where we want the result to come back. Or we have a case failure where we want the error to come back. Yeah? Now, something that's great about enums in Swift is compared to the enums in other languages that are C-based, they are much richer. Yeah? An enum, for example, in Objective-C is essentially just an integer. Yeah? It's a number, yeah, and that's it. Yeah? In Swift, anything can be the underlying value. Yeah? Could even be a string. Yeah? An enum can have any data type. And the other thing you can have is so-called associated values. Let's look at an example. Here we define an enum for the kinds of errors that could occur in this API. And you see here, I've tagged the associated value for the unexpected result as string, and the one for the restful error as NSError. And the restful error I reserve for those kinds of errors that come back from NSUL data session, for example. Yeah? And here's a definition for the result. Yeah? Again, this is success or failure, but we want the failure to have a request error as the associated value. Yeah? So this is using the concept of associated values both for the kinds of errors and also for what the attached, the associated value for the failure is. Yeah? And this is how you could use that. You could say request result dot failure bracket dot unexpected result, because the context is clear. I don't need to write request result dot unexpected result. That makes it a bit shorter. And then the string I want to sort of put into this variable, you could say, this associated value. And that's another example. Yeah, imagine the NSUL data session completion handler comes back. I check if the error is not nil, and if it's not nil, then I can call my completion handler and pack this NS error into the restful error, into the failure, and that's what I return in the completion handler. Yeah? And the great thing is, associated values can also be generic, yeah? Because we've given a type to the failure, but we haven't done anything for the success. Now, as said earlier, we don't want that to be generically typed with it or any object in Swift, but we want it to have a concrete type. And that's something you can do with generics. Yeah? I pass the angle brackets with a t. This is basically a type parameter. And then I use this t a little further down. And now I have basically an endless number of request results. Namely, for every type t that I pass in there, I get a specific request result. So that could be a string, then I have a request result that returns strings. Could be an array of strings. Yeah? And here's an example how you would use that. Yeah? This method foo returns in the completion handler a result that is a single string. And that's how you then would also call it completion.success, and I pass in the text. And I get this state, this result success, and it has a single string attached in it. Yeah? And what you also can do is you can type alias to your heart's content. You could have one completion that's just one string, and the second one, the string array completion, is an array of strings. Yeah? So if I replace this here, the completion doesn't change. Yeah? I still return a success with a single text. Yeah? If it's the array completion, then I need to return an array. And the other thing, what's kind of cool with type aliases, because it's if you don't use a type alias but do the whole thing inline in the function, if you want to make it optional, you have to put brackets around it and a question mark. And here you just add the question mark at the end of the type alias, and suddenly our completion handler is optional. Now, another thing, when you do that, you end up with lots of type aliases, yeah, for all the different kinds of things that you expect from your web service. So a smart person named Chris Ladner suggested, how about we make type aliases generic? Yeah? And that's something that's implemented in Swift 3. So you can write request completion, angle bracket t, angle bracket, and then use the t as the request result. And this way, now suddenly you don't need any type aliases anymore. If you write it like that in your API method, it's even shorter than having a long speaking name like string array completion, because it would just be request result, angle bracket, square bracket, string, square bracket, angle bracket. Yeah? Now, speaking of error handling, yeah, in Objective-C, we are used to passing around these NS errors. And as I said, the problem that I have with NS errors is you never know how well localized is it. Yeah? Is it even suitable to be shown to a user? Yeah? If it's coming from NS URL session, and for example, the internet is turned off, you get a good response that might tell the user, yeah, the internet might be off. Okay. But if it's an error that comes from some operation that I did 3 levels deep, yeah, I don't know, is that something that I can show to the user? So in sort of an attempt to address that, Swift has a different error handling method that's based on the ErrorType Protocol. Documentation says it's a type representing an error that can be thrown. Yeah? And if you look at the header, this is what you see. Yeah? Aha, it says it's called ErrorType, but then it's actually a protocol, but it doesn't have anything in there. Well, indeed, it does have something in there, but it's invisible, namely an underscore domain and an underscore code. Yeah? And this is what the compiler uses for, in the following slides, I will be mentioning NS error magic. Yeah? Because an error type can always be typecast into an NS error, and that's where it gets the domain and the code from. And by the way, in Swift, with the grand renaming, they realized, well, actually it's not a type, it's a protocol, so let's call it instead error protocol. Now, we've implemented all of that. Yeah? How do we deal with this result that's a success or a failure. Yeah? We do that with pattern matching. So I've instantiated a web service here where I'm calling the function foo and I'm getting a result. Yeah? So I use something that goes really well together with enums is a switch. So I can say switch result. If it's a success, and here's the first special thing that you also haven't seen before, you can combine a case with a let. Yeah? So in Objective-C, you could just say if case this, case this, case this. In Swift, you can do case this and let a certain variable be this associate value in here. And it doesn't matter whether the let is here after the case or in front of the array. I will be doing it both ways. Depends on your own personal preference. But this way, I extract the array out of the success, and then I just print it here in this case. There's also the possibility that you don't really care what the error was. Yeah? If it's a login, and if it fails, then I display login wasn't successful, whatever the reason was. Yeah? So this you can do with an underscore in Swift. Or if you do care, yeah, you can get the, again, case let.failure error. That means afterwards in the variable error is the error type that came back. And then I'm using the NS error magic to turn this error into an NS error so that in the line after that I can log the localized description. And something that's even fancier, took me a day to actually figure this out. You can also do if case.failure let error equals result. That's I don't know why they invented that. You could say, oh, a switch can do everything. But one reason might be if you just do a switch success, switch failure, let error as NS error, then a compiler complains that you haven't covered all the cases. I don't know why. Yeah, and this is a way how you can have both the conversion to NS error as well as the success, and the compiler not complain that you haven't treated all the things. So in order to digest this, it's basically a if case. If case and enum equals the variable. It's the same as switch variable case. And then we have the let in here that assigns it to the variable. Yeah? Now, speaking of the localized description, yeah, we saw in this NS error magic, we have this underscore code and this underscore domain, but where do we get a description from? Yeah? And I think the whole point of this, that Apple is making it sort of hard to fiddle some description in there, is you're not supposed to do that in your frameworks, but rather you should let the errors bubble up to the app level, and then where the interaction with the user is, you're supposed to then find a proper text or somehow a representation to show the user what happened. Yeah? So that you don't worry about localizing stuff 3 levels down. Yeah? Also, if I'm making a framework, say on GitHub, I don't know all the languages that an app will be localized in that is using my framework. Yeah? The app maker knows, okay, these 30 language we need localized error descriptions for. But one thing that you can still do is you can register a so-called user info value provider for a certain domain. And if you don't set a domain, the default domain for all error types is the name of the module. Yeah, my module in this case was called test. And then the name of the enum, request error. Yeah? And if there's, well, you can provide multiple values. You can provide values for the underlying error, for example. In this case, we're only interested in the description key, and so I just return something. And you could easily imagine that I have in my strings file, for example, error code 1, yeah, that's the one I return here. Error code 2 is the one I return here, and so on. Problem is, it requires iOS 9 or OS 10.11. Yeah? One way how you can sort of then get your request errors to actually return the proper code, yeah, is since this enums in Swift can also have computed properties, you can implement the underscore domain and return my domain. Then you would use my domain instead of on the previous slide test.requestError. And you can switch self, which is the different kind of enums. And in the case of RESTful error, you return 1. In the case of unexpected result, you return 2. And then your user info value provider gets this domain and this code for this error, and same domain, other code for the other one. Yeah? Though I'm more or less mentioning that sort of as an introduction where I really want to go, because there's a smarter way to do that. Yeah? Namely, we have the same situation. I have my web service that I call the function foo of success we dealt with, but this is something cool that you can do is you can do a case over multiple levels. Yeah? In this case failure and a certain enum from the error, yeah? And then let text of that. Yeah? And by the same token, so I've got this one error where I have a string as associate value, and the other I have an NS error. Yeah? And so I specifically, I don't use this NS error magic here, but rather in the second case, I extract the NS error that I got back from my underlying operation. And in the first case, I get the text that was attached to the error type. Now let's speak about generics. Something that's cool in Swift is consider, for example, you have a JSON dictionary, which is a dictionary that came out of JSON text that came back from the server. And I can define a protocol, JSON initializable, that takes such a dictionary to initialize a model object. Yeah? As I said before, I don't want to work with dictionaries, I want to work with proper objects. And that's all my objects that I work locally with are such JSON initializable objects. And then to use that with a function, here's a generic function that takes a type parameter t, but this type is restricted to the types that implement also this protocol. Yeah? We'll see in a second how I use that. Here's something more elaborate. I'm creating a data task for my request to the server, and I'm expecting back, in this case, a single t. Yeah? And this t has to be JSON initializable. Yeah? So for example, I'm requesting from the server a list of categories. No, not a list of categories, rather a single category. Yeah? And I want, in the end, my result to be a category object. Yeah? So that's how I get it. Yeah? So I'm creating a data task for my request. I handle the error case, so if there's an error coming back, and in this case, the data task for request, that's the old school thing, yeah? That still has a result and an error. So if the error is not nil, then I pack it into a failure and call the completion handler with it. In the other case that I didn't get a failure, then I must have gotten a result, and this result must be a JSON dictionary, yeah? Because that's what I'm expecting, a single JSON dictionary that I now want to turn into a model object. And there should be more than 0 keys in this dictionary. Yeah? So the only thing that I need to do is t.init, yeah? Because up top, the t is restricted to be JSON initializable. That means the compiler knows, okay, there is an init that takes a dictionary that's of type JSON dictionary. And then I've turned this JSON into a model object, and that I return as the payload of a success. Yeah? Or in the other case, if everything else, if I got to the third case, then that was not what I expected, so I still want to return an error. Yeah? And so this function, data task, then I would do data task.resume, and it would go on and do that, and I end up with either the failure or the result. Now, same name of the function, but one thing is different here. The t in this case is an array. Yeah, I want an array of t's, but still each individual t should be JSON initializable. Yeah, it looks almost the same. Yeah, if there's an error, I pack this error into a RESTful error. Otherwise, I expect an array of JSON dictionaries. Yeah, so basically a JSON that is an array, and there's dictionary, 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 dictionary. So I iterate through these, and each individual one I pass to my init, get the entity, add that to my return array, and then I call success with my return array. Yeah? And because this one type is different, it's a different function. So in the other case, well, I didn't get back what I expected, so I returned that. Now, one thing that I tried when researching this talk is, can you actually call a specific version of this function? Yeah, like passing in category as a class. And the compiler says, "Niet." Yeah, you cannot specialize a non-generic function. And the reason for that is the specialization of the function happens in the context the function is being called. Yeah? So let's look at this example. There's a API method that I implemented to retrieve the categories, and I'm expecting to get back an array of category objects. Yeah? If I were to write it like that, yeah, I'm calling the response processing data tasks method, either one of those that we saw on the previous slide. Here the compiler would complain that it doesn't know which of these you mean. Yeah? But if you do something like that, you just use result somehow, now the compiler knows. And it's a bit of a mental stretch to follow how it is, so I painted it out here. Yeah? So we have this category completion Typealias that tells the compiler, okay, we are dealing, the completion handler returns an array of categories. So from this it can say, okay, we're calling this, so result must be basically an array of categories. Yeah? From this it can see, okay, then this must have been an array parameter with category, and so from this it can say, okay, apparently we are talking about this specific function, the one that is dealing with this array, as opposed to the one with just a single type. And that's I call it multiple level type inference, or you could also basically, it goes in reverse, yeah, how a function is used, yeah, like if you have let some array equals a function that it knows, aha, in this case it's expecting an array, so it can only mean this function. Yeah? And if it's not clear, the compiler complains about something being ambivalent. Yeah? So it turns out I'm much faster than I thought. Yeah? So we have lots of time for questions, because one thing that I wanted to point out, the thing that I'm talking here about, that's not really my idea. Yeah? Somebody once said, only steal good stuff. So if you see something, somebody does something smart, try to understand it and incorporate into your own methods. And that's what happened here. So I was in the situation, I was constructing a completely new API for a completely new project, no Objective-C anywhere in sight. And so I figured, well, that's a good time to reevaluate, should I do it like I did it in the product layer API, or should I do something smarter? And that's when I basically step by step came to this conclusion. But it turns out somebody before me had this very idea, namely Rob Riggs. Yeah? And there is a great GitHub project and component. Let's briefly point out the differences. Yeah? Apart from the name, he just calls it result. Yeah? I call it request result. He's got the error here as a type parameter, because he doesn't know what kind of error type you're going to use. So you have to specify that as well. The other thing that's nice in his approach is he's got initializers for success and for failure. So it might be nicer to write something basically result bracket value colon, and then you have the value to say, okay, I'm going for the success case versus result bracket an error type. The advantage is you don't have to specifically write, like in my case, dot success and the return or dot failure, but it's in both cases is basically a different initializer. Yeah? The other thing he did is he's using result type, and that's a trick he uses so that it's both Swift 2 and Swift 3 compatible, because the only thing that basically does is depending on the Swift version, it defines it either as error type or error protocol. So the whole result thing also compiles with Swift 3. Yeah? And the last thing, there's also custom string convertible and custom debug string convertible. That is, if you print such a result object, you also get a nice message. This is a success with this content. This is a failure with this content. Yeah. So many thanks to Rob Ricks, yeah, who was, to my knowledge, the first one who said, okay, let's do result like that, and it greatly helped me sort of figure out this concept that I wanted to present today. So in closing, well, that's the URL where you can get it on GitHub. But in closing, I want to say you should really think of situations where you have an either or, because that's a perfect scenario for using Swift enums, yeah? Especially in connection with these associated values, so that you can put one or more variables basically into these enum cases and give them additional meaning, yeah? Sort of this payload. Yeah? Also, if at all possible, you should use error type instead of NS error. If you get an NS error back from some foundation network, okay, package that into an error type case. But apart from that, I wouldn't recommend trying to get localized descriptions going for all your errors. Yeah? But have the localizing of the errors like really at the top level of your app. Also, generic functions are cool, and they are even cooler if you use type constraints. So when you do, they call it protocol-oriented developing. That is, you think of certain attributes something should have. Like it should be initializable with a JSON dictionary. Yeah? Then you have a protocol, JSON initializable. Or in another project I recently did, we had lots of shapes, yeah? And some shapes might be strokeable because you can stroke their path on the graphics context. Others might be fillable because they are a closed shape. So you're basically thinking of what is this attribute it has, yeah? And then what you also can do in Swift is make default implementations for certain functions that are part of these protocols. And type constraints then allow you to make generic functions that need a specific set of such attributes to be present in an object. Yeah? So this was a very simple example because it's only using JSON initializable, but you could have any number of such attributes. It needs to be JSON initializable and it needs to be strokeable and whatever. And the cool thing is that then the compiler takes this intelligence of how you use it and finds this specialized function for it. Yeah, like we saw before, I have the same name. They only are different because one type is a single type and the other one is an array. Yeah, and that also simplifies the code. Yeah, because I know in one case I'm just expecting a single value, so I don't have to do things like if my return was an array, then do this, otherwise do that. But I have to completely separate functions which are easy to understand and easy to reason about. You should be critical about Objective-C compatibility just because you have been interfacing all the time with Objective-C before, there might be this new project, yeah, where you can do everything from scratch, and then there might be many situations where reaching for this higher fruit, yeah, these things that don't work in Objective-C might prove beneficial and might make the code more readable. So that's my basic message of this whole talk. If you can reach for the high fruit, you want to be the giraffe that gets away from the lions, the Objective-C lions. So in the end, your code becomes more easy to understand and shorter and more concise. So thanks. Thank you.